The world was still warm. There were no polar ice caps, forests stretched into high latitudes, sea levels were high, and the atmosphere carried far more carbon than today. Extinction had failed, but evolution had not paused. Across the equatorial wetlands of northern Gondwana, heat allowed reptiles to reach extraordinary scale. In the swamps of South America, a serpent longer than 13 meters ruled the rivers, the Titanoboa. Its immense size was made possible by constant warmth. Cold-blooded giants thrive where temperatures rarely fall. It hunted fish, crocodilians, and unwary juvenile dinosaurs along muddy banks. Even apex predators gave it space. So this greenhouse world was not stable. Around 56 million years ago, the climate shifted violently. Carbon surged into the atmosphere in what would later be called the Paleocene Eocene thermal maximum, PETM. Global temperatures rose by 5 to 8 degrees Celsius in only a few thousand years. Oceans acidified, rainfall patterns destabilized, wetlands expanded, then shifted unpredictably. For a time, tropical life flourished. Insects multiplied, forests thickened. Titanoboa reached its greatest range. Yet volatility favors flexibility over size. Large-bodied herbivores dependent on stable vegetation cycles began to suffer. Some temperate sauropod lineages disappeared from mid-latitudes. Cold-adapted armored dinosaurs retreated or vanished. Range contraction began. As the Eocene unfolded, warmth reached its peak. Forest blanketed much of the planet. Dawn redwoods and swamp cypresses grew at high latitudes as well. Palm-like plants reached for north. The world felt uniformly humid and green. Dinosaurs remained dominant across most continental systems. Hadrosaur descendants thrived in dense flowering forests. Abelisaurids continued as ambush predators in Gondwana. Tyrannosaurid descendants persisted in Asia, smaller and leaner, but their Cretaceous ancestors adapted to complex forest terrain. Feathered theropods diversified widely, insulated enough to exploit cooler uplands and seasonal regions. Intelligence, first kindled millions of years earlier, endured within troodontid lineages. They refined the use of stones. They organized communal nesting grounds. They adapted seasonally, but they did not conquer. They remained participants in the world far larger than themselves. Meanwhile, mammals diversified in the shadows. In the canopy, early primate-like forms developed grasping digits and improved depth perception. Bats entered the night skies. In coastal areas, early whales such as Basilosaurus swam warm, shallow waters. But mammals did not inherit the earth yet. They shared it. Around 50 to 40 million years ago, India collided with Asia. Mountain ranges rose, atmospheric circulation shifted, monsoons intensified, and seasonality sharpened across Eurasia. Stable tropical corridors were fragmented. Large herbivores requiring constant forage suffered further range reductions. Sauropods became increasingly restricted to equatorial rainforest belts. Outside those refugia, smaller and faster herbivores proved more resilient. Then the planet began to cool. As Australia separated from Antarctica, a powerful circumpolar current formed. Heat redistribution weakened. By 34 million years ago, permanent ice sheets began to form over Antarctica. The greenhouse world ended. The transition, the Grande Coupure, reshaped ecosystems across continents. Forests retreated from continental interiors. Deciduous trees replaced evergreen dominance in temperate zones. Open woodlands appeared where dense canopies once stood. Several tropical dinosaur clades vanished from mid-latitudes. Ankylosaur lineages largely disappeared outside equatorial refuges. Giant crocodilians declined in cooling regions, surviving primarily in tropical rivers. Feathered theropods, better insulated and more adaptable, expanded into temperate habitats. Mid-sized predators evolved for speed rather than sheer mass. Sauropods endured, but only in the most stable equatorial forests of South America, Africa, and parts of Southeast Asia. They were no longer global giants, they were relics of an earlier world. During the Oligocene from 34 to 23 million years ago, the icehouse state stabilized. Global climates grew cooler and more seasonal. Sea levels fell, continental interiors dried. Forests continued to contract, open habitats expanded, and early grasslands began to spread. These emerging grass-dominated environments favored mobility and efficiency. Smaller ornithopod dinosaurs adapted to graze tougher vegetation. Theropod predators became more cursorial, pursuing prey across open grounds. Mammals too evolved larger grazing forms in some regions. In Africa and parts of Eurasia, mixed megafaunal communities formed, reptilian and mammalian herbivores sharing landscapes. Yet dominance remained uneven. In the tropics, dinosaurs still held ecological authority. In temperate grasslands, mammals gained ground. On isolated landmasses such as Madagascar, reduced dinosaur diversity allowed mammals slightly broader evolutionary space, but even they remain cautious. Intelligence among Troodonted descendants persisted through cooling. They adapted to forest edges and open terrain. Their use of stones became more consistent and more prominent. Their social coordination was sharpened. They survived not through conquest but through flexibility. In the oceans, change was equally profound. Marine reptiles, once supreme, declined in cooling waters. Sharks diversified and strengthened. Early lamniform ancestors grew larger and faster. Whales expanded their ecological rules. By the mid-Miocene, around 15 to 12 million years ago, the world had transformed. Grasslands stretched across continental interiors. Equatorial forests sheltered the last great sauropod refugees. Feathered theropods dominated temperate ecosystems. The age of dinosaurs endured, yet it was no longer uniform, no longer unchallenged, and no longer secure. In the deepening oceans, a new apex was gaining strength.